This is just a quick video on Chapter 6, Time Value of Money for Finance. You should read the chapter 6, and review the PowerPoint slides for the chapter. But we're going to do something a little bit different because we have a tool at our disposal that the textbook doesn't use, which we're going to use Excel to solve these problems using the time value of money. We are not going to use the old school version of these functions, which is looking up a factor in a table. And that's what we used to do when I took this class back in graduate school. We had to look up the factors in the table, but we have this Excel at our disposal, so we're going to use Excel to solve all of these problems. And so what are we talking about when we are talking about time value of money problems? Well, in the last chapter, we talked about how one of the risks associated with lending money was the maturity risk. And that risk is that a dollar today is worth more than a dollar in a future time period. So a dollar in your pocket you can use to invest it and you can get a return on that money. A dollar in somebody else's pocket is worth nothing to you until you get it, right? So we need to factor that in when we're discussing various types of investments. One of the tools that we will use in solving these problems is trying to draw a timeline. So let me get a little picture in here. All right. Here is a little timeline. So what information happens in these time value of money problems that we need to factor in? Well, we have a dollar amount at the beginning, or the present value. We have a dollar amount in the future, and that's our future value. Also, along this timeline, we have an interest rate. So we're going to call that K, our interest rate. And you'll remember that letter K from our last chapter. So K is our interest rate. So our money from day one to the end of time is going to accumulate at K, the interest rate. And we use compound interest. So instead of it being just each year you're getting this interest, that interest rate builds on top of itself at various intervals. So you're earning interest not only on the dollar amount that you invested, but also on the interest that you earned to date. So it's compounding itself. The other thing that you need to know is how long is this time period in my timeline? And so you have N, which is the number of periods. So how long is this timeline? That is a simple single sum problem. And we have another kind of problem as well. And that other kind of problem, so this is a lump sum problem. Call that a lump sum. So at the beginning, I have a single dollar amount. I put it into an investment account. It earns me K interest. And after N number of periods, I have my future value. I also have an annuity problem. And what is an annuity problem? Well, instead of having one present value, I have this same picture up here, except I'm going to put additional deposits in the bank. So instead of just putting one deposit in the bank at the beginning, I'm going to continually add additional amounts. So let me draw that. I have my timeline. I still have a present value. I still have a future value. I still have K, my interest rate, and I still have N, the number of periods in this timeline. However, instead of that one contribution at the beginning, I'm going to give money at regular intervals over time. So I'm going to have deposits along this timeline as I go. Okay. So at regular intervals, I am depositing more money. And that's called an annuity. Each one of these along the timeline is a payment. So that is denoted PMT for payment. Okay, so how am I going to go about solving one of these problems? Well, the first thing that you need to do is figure out, is it a lump sum problem or is it an annuity problem? And it should be fairly clear from the problem that there are multiple deposits or there's one deposit. So you need to first, this is step one, figure out, is it a lump sum or is it an annuity problem? There are also two types of annuity problems. There's an annuity, which is that the first payment is going to be made at the end of the period, or there's an annuity due, and that's when the payment is done at the beginning of the first period. So you have both an annuity and an annuity due. So let's try and copy this and show you an annuity due. And the reason that we have to calculate that differently is that that first deposit is going to earn interest in that first period. Whereas if it's deposited at the end of the period, it doesn't earn that first period of interest. So an annuity due is going to be a little bit higher than the annuity each time because it has that extra period to earn the interest. Okay, so now what do I do to go about solving these problems using Excel? There are 5 different functions: present value, future value, PMT for payment, K, the interest rate, and N, number of periods. So these are the 5 things that are included in each one of these problems. If it is not an annuity, that payment's just going to be 0. There's going to be a present value and no payment. So if you had a lump sum problem, you're just going to ignore the payment piece. All right, so what are our functions to solve for these various things? Our functions are present value, future value. Our payment function is PMT. Our function for solving for the interest rate is actually rate. And the formula for solving for N, the number of periods, is NPER. Okay? PV, FV, PMT, rate, and NPER. So item, and this is our formula. Okay, so that's what you're going to use in each one of these problems. You're going to use the rate formula for solving your problem. Okay, so here's an example. Let's do an example of each one of these. Okay. Also, I just want to let you know, on Moodle, there are 2 things that are going to be helpful to you. In this course-wide resources, there are some documents. One that is a PDF that summarizes these Excel functions. There's a Word document with some problem help on those problems. And then there's another one when we come up with some amortization schedule problems. There's a Word document here on how to make one of those schedules. We'll talk about that. Okay, so for example, what would be a problem where we have to solve for a present value? Okay, so let's say I want to put some dollar amount into a bank account, and after 5 years, I want to have $1,000. Okay, so I'm trying to save up $1,000. So how much do I need to invest now to have $1,000 in 5 years I need to have an interest rate, let's say 8% interest. Okay, so let's solve this problem. How are we going to do this? We use the Excel function. So equals, and we type PV. Now, if you click on this function, it will come up. That is not working. If we click on this function, it will come up with this function arguments box. And notice we have our 5 different things, okay? Our PV is what we're solving for, our rate, our number of periods, and our payment and future value. So after you click on this function, after you've typed in PV, it will give you a space to put in all of the information that's given in the problem. So we were given an interest rate, 8%. We were given number of periods, 5. This is not an annuity problem, so we are going to skip over payment. And future value, we want to have $1,000. So how much do I have to put in a bank account to have $1,000 at the end of 5 years in a bank account that is earning me 8%? And the answer to that, $680.58. Now you'll notice that that's negative. That's just a function of how that formula works. And so you want to make sure that you put a negative at the beginning, because obviously you're not putting in negative $680, you're putting in $680. So you want to make sure that you adjust for that factor that it's going to make it a negative number. Okay, now let's do the opposite. How much will I have after 5 years at 8% if I deposit $680.58? Okay, so now we're doing the opposite. We're solving for how much am I going to have at the end if I deposit that amount. So we're going to click on equals, and we'll put this time FV for future value. Let's click on our little function, equals FV. Click on our little function to get our function arguments box. What was our rate? It was 8%. What's our number of periods? 5 years. Again, this is not an annuity problem, so we're going to skip over payment. And the present value we said was $680.58. Okay, say okay, and look, we have $1,000. And again, that's going to be negative, so we want to put a negative at the beginning. That's again just how that function works. Okay, now for PMT, let's say instead of depositing my $680 at the beginning, I'm going to make an interval of payments. So for example, every paycheck I will put $100 away. So let's say how much will I have? Let's solve, how much do I have to put away? Do I have to deposit annually for 5 years to have $1,000? So instead of one deposit, I'm going to have multiple deposits. How much do I have to have for each of those deposits to get to $1,000 at the end? So this is a PMT problem. Let's pull up our box. Our rate, 8%, number of periods, 5. You can skip over present value. I don't know how much I have now. It's a annuity problem, not a lump sum problem. And I have my future value I want at 1,000. Now there is this type part of this function, and that is for determining if it's an annuity or an annuity due, okay? So I have to put either a 0 or nothing on there if it is a regular annuity. If it is an annuity due, if I want my deposit to be at the beginning of the period, I have to put a 1 in that type box. Let's just assume that I'm going to make my first deposit at the end of the first year. So let's just put a 0 or put nothing in there. The result, $170.46. I can obviously make that a negative. I'm not going to put a negative amount in my bank account. I'm going to put a positive amount in my bank account. So at each of those 5 years, I have to put $170 into the bank account so that at the end I will have $1,000. Okay. Now, what about number of periods? Let's skip over rate for a minute because we have this problem that we're working on. For number of periods, let's say how many deposits of $170.46 do I need to make to get $1,000 if I get 8% interest? Okay. And this is a number of periods problem. So NPER, and I can click on this function, my rate, 8%. My payment, $170.48. I don't have a present value here because there's no lump sum. It's all an annuity. My future value, I want to be $1,000. And my type, I can leave alone. I want to make this payment negative, okay? So again, this function is going to calculate a negative. So if you're trying to calculate the number of periods, you want to make that payment negative. And it will come up, as you can see, with almost 5 years. It's pretty close, okay? Just because of rounding, it's a little bit less than 5 years. So I need to make 5 deposits of $170.46. Okay, finally, we have an interest rate. So what rate of interest would I need to earn to get $1,000 at the end of 5 years with this deposit of $680.58? So in this case, I'm solving for the rate in this problem. So that is the rate function. Pull this up. I have 5 years. I have a present value. This is how much I'm going to deposit, $680.58. The future value I want is $1,000. I have to make one of these negative. It doesn't matter which one. I'll make the present value negative. So what interest rate do I have to get $1,000? And it will come up with my 8%. Magic. Okay, so that's how you solve these problems, and we will do some examples in class, but this is just to show you that we will not be using the textbook way of doing this. This is how we're going to do it, and we have some time value of money cheat sheets for you in Moodle. Thank you.